Now let's talk about a very important rule for the differentiation, which is called the chain rule. Okay, so this rule is really important. It's the most important thing one of the most important things in the calculus 1. If you don't know this rule very well, you cannot continue anymore. So keep in mind, do as many as possible exercise for the chain rule. So we have learned some functions that we can use the basic derivative, basic rules to find like the square root of x, right? We know that, and we also can take the derivative for this kind of t cube, right? And we also know we can take the derivative for the tangent, right? Or for the e function, right? Exponential function e with base e. So we can use the basic rules to take the derivative. Okay, of course, the derivative of the natural log, right, of x. But if we have another function, which is for example, which is the square root of 5x minus 8, for example. Okay, so some students may think, okay, it must be equal to, okay, it's equal to this is the derivative of 5x minus 8. This is to the 1/2 power, so we write it as a power form, then take the derivative. So this one is 1/2 and 5x minus 5 minus 8, 1/2 minus 1. So this would be negative 1/2. Okay, so something may think this one is right, but actually it's wrong. It's partially right, but the result missing some number. You can see. Let's look at, but how do we do that? Okay, so if we don't know how to do that, we need to use the definition to find the derivative, right? So do you remember the definition, the limit? H approaches 0, fx plus h minus f of x over h, right? If you plug in, so this would be f of x plus h. You replace the position of x with x plus h, so this is the square root 5x plus h minus 8 minus square root 5x minus 8 over h, right? How do you evaluate? You plug in h, you will get 0 over 0 from that. That means you need to modify it. You remember we have the technique. We multiply the conjugate, which means 5x plus h minus 8 plus square root 5x minus 8 over the same thing, right? If you are not familiar with that, you can go back to see the examples when we talk about the techniques for the limit, right? So here, I don't want to spend much time on this calculation. At last, you will have 5 over 2 times 5x minus 8 to the negative 1/2. So compare this result and this one. There is an extra number 5. There is an extra number 5. So, but in this result, this 5 disappears, right? So that means for this kind of function, the power rule is not enough. We should have another rule to deal with this kind of function, which is called the chain rule. Okay, so here, let's look at this one. So this is actually the composition of two functions, okay? This is the composition of two functions. So which is composed with, if we let h of x, h of u equals square root u, and g of x, u equals g of x equals 5x minus 1. So this is the f of x, which is actually the h of g of x, right? Which is the composite function, h composed with g. So now we need to derive we need to get a rule to take the derivative for this function, for this composite function. So this is called the chain rule. So here I give you the result for the chain rule. So suppose we have f composed with g, okay, which means f of g of x. We denote this is the function of x, so we denote this one as capital F. So we want to take the derivative. We take the derivative of this capital F because it's a function about x, right? You can always take the derivative, which means the derivative of f of g of x. What's that? That is the derivative of f, then plug in g of x times the derivative of g. Okay. So here, if we use, so this is called the chain rule. In other words, if we let y equals f of u and u equals g of x, then this y here is capital F, which is f of g of x, right? So this is actually the capital F. So if we we use the Lebanese notation, we use the dy over dx. This is called the Lebanese notation, which represent Lebanese notation. Okay, so dy over dx, which means to take the derivative about x for this function, this composite function, from this result here, which is f prime of what? Gx is u, so u times g prime of x. So be careful. So here, this prime and this prime means different things. The first prime means the derivative about u. We take the derivative for this function, right? F, the variable is u. The second derivative means the derivative about x, because g is a function about x. So if you are not familiar, if you don't like this way, so let's use the Lebanese notation. It means f, the derivative of f, which means about u. So this is dy over du times du. U is g, right? dg over du, so it's du over dx. U equals g. So you can see this one, the dy over dx for this composite function, we have some bridge, right? U. We use u as a bridge. We take the derivative about u first, then multiply the derivative of u about x. So it looks like you can cancel out the du and du, right? One is on the top, the other one is on the denominator. So you can cancel out. It looks like you can cancel out, yeah. But actually, this is also the chain rule. So now let's go back to our function. This function again, this is the f of x equals, we use different notations, so I don't want to use the lowercase f to confuse you. So that we use capital F, which is 5x minus 8, right? if we let f of u equals what? Equals the square root of u. G of x, u equals g of x, which is 5x minus 8. Okay, so f prime of u, which means the df of du, right? So this means this is the 1/2 u to the negative 1/2, right? We use the power rule. U prime, which means du over dx. So this means this is 5. So from this formula, we have, or from the chain rule, we have the derivative of f, which is actually this capital F is actually f of g, right? So the derivative of f of g. So this is by the result we have, which should be this one multiplied by this one, right? One half u to the negative 1/2 times 5. So this is, if you plug in u equals g, which is 5 over 2 times g is 5x minus 8 to the negative 1/2, right? Then you will get the correct answer. So you can see this 5 is actually the derivative of this inside, the expression under the square root, right? This 5 is from here. So here f, if you have the composite function f, here f is called the outside function. Here g is called inside function. So roughly speaking, for the chain rule, which means the derivative of this composite function, which is the derivative of the outside function times the derivative of g inside function. Okay. So this is the chain rule. So we can see this is the derivative, which this is the chain rule, right? Which is f prime of gx times g prime. So this f prime means the derivative of inside function, outside function. And this is the inside function. We just leave the inside function. And this is the derivative of outside function. Of inside function. So the question is how to identify for a composite, what is the outside function and what is the inside function? Okay, so here is a quick way to identify the outside function and the inside function. So for example, we still look at this problem. This is the capital F is equal to square root 5x minus 8. If we want to, do you remember how to evaluate f of 2? We 5 multiplied by 2, right? then subtract 8, then take the square root. So what is the last operation when you evaluate this function? The last operation is the square root, right? Is the square root. So then we can say the square root function is the outside function. So the square root function is the outside function. So in other words, the outside function is the last operation when you try to evaluate this composite function. So the rest part would be the inside function. Okay, so here is, so we need to look at more examples.